RCART provides 3 versions of software for problem solving. RCA2GO is software that is optimised for plant and equipment problems. The software addresses ongoing conditions that lead to a lack of performance and events that have happened and where we need to prevent a reoccurrence, and also future events. For example, a reliability-centred maintenance or preventive maintenance optimisation study seeks to identify the root cause of failure of a future event. RCA2GO incorporates cause models for common equipment types and for human factor analysis based on Reason's causation model, which is the basis for the incident cause analysis methodology and for the Federal Aviation Administration's Human Factors Analysis and Classification System. SHEQ2GO is optimised for events, especially where there is a string of events that have been influenced by human behaviour. Workplace injuries, quality issues and environmental incidents resulting from faulty operations are often suited for analysis using SHEQ2GO. SHEQ2GO incorporates Professor James Reason's causation model, or Swiss cheese model, and uses cause labelling to reveal systemic problems. SHEQ2GO documents the ICAMS, Incident Cause Analysis methodology for problem solving. Solver2Go allows the system administrator to select elements from RCA2Go and SHEQ2GO to create a problem-solving tool customised to suit the particular needs of an organisation. This video provides an overview of the SHEQ2GO software and how it may be used to document ICAMS investigations. SHEQ2GO allows users to customise and edit forms to gather information. Different businesses capture different information. This example is typical of what might be used by a flying school. The form is generally similar to the form used by the aviation regulator. In this case, the form has a simple data gathering and problem solving process in line with the regulator's recommended practice. People may sign off on their statements, so preceding information cannot be altered, just as they would on a paper form. In this form, users are asked to decide whether the issue justifies an ICAMS investigations. Most issues would normally not justify an ICAMS investigation. But in this case, people suffered injuries and an aircraft was destroyed. So yes is clicked, causing the ICAMS investigation procedure to be shown. Users may customise the ICAMS process to suit their particular needs. In this case, the system administrator has included a checklist to remind investigators to address key issues as soon as possible. Perhaps there is a need to define team members. Fields may be added to record and share a plan for the investigation. The system administrator then provides menu buttons to lead investigators through the ICAMS process. This button takes investigators to an Ishikawa or fishbone diagram where they start gathering data. It is helpful to show 5 to 7 topics that cover the range of factors that may have contributed to the issue. Here the topics are MMPEMM for measurement, material, personnel, environment, methods and machines, which are common themes in manufacturing. Data gathering is helped by brainstorming. Investigators can add known and hypothetical causes and events based on their experience and imagination. Every idea is a good idea in brainstorming. Evidence can be gathered at a later stage in the process to test and confirm or reject ideas. The software automatically stores and labels these ideas to assist with analysis later in the investigation. Users provide a short description of a few words. The description field allows for an extended description which may be edited as more information becomes available. Users can select whether the idea is a cause, condition, or an event. The automatically created labels allow the software to sort and present these ideas as the investigation progresses. The gathering of information is an iterative process. Investigators will return to this fishbone diagram to add ideas as time goes by. For now, they close out of this screen and return to the ICAMS process. By this time, the investigators will have formed a view on what was the top event. This can be thought of as a problem statement, or sometimes the point where control was lost. In this case, the situation was an engine failure in a single-engine aircraft as it approached to land. The aircraft crashed into a house in a suburban street and was destroyed. In this case, the top event was the aircraft landed in a suburban street. The investigators now develop a timeline of events that led up to the top event. The timeline may be represented as a simple string of events in time order, or it can be represented as a tree with each branch tracing a different theme. In this case, the timeline has two branches, one branch for the aircraft and the other branch for the pilot. In more complex incidents, with multiple people and systems involved, there may be many branches of events leading to the top event. A timeline may also be developed for the events that followed the top event. In a way, the events before and after the top event are disconnected. There are many reasons why the aircraft might have crashed at that particular location. There are a different set of events and causes related to the time after the top event, like the arrival of emergency services and effects on the pilot and her family, and the owners of the house and the aircraft, and on the aviation regulator and the aviation industry in general. The aircraft could have landed in a wide deserted street, but sadly, in this case, the aircraft skidded into a house. The pilot escaped, but a fire followed. The pilot was injured and the aircraft destroyed. Luckily, the occupants of the house were not home, but the house was severely damaged. The string of events irradiate away from the top event as emergency services are called. There may be delays or problems experienced in attending to the initial emergency. There will be a series of different events unfolding for the injured pilot and her family, for the building owners, for the aircraft owners and operator, and the organisation that maintained the aircraft. Let's save and close out of here and return to the home page. You will remember that we used the SHEQ2GO diagram to brainstorm for ideas. The development of the events tree before and after the top event will have given us more ideas that we can add to the library. Let's return to the time before tree to see how we can bring the ideas out of the library and organise them using the timeline of events. This is the time before event tree we saw earlier in this video. Click on the event that you would like to add a cause to. A red line forms around the selected event. Then click on the library button to show the causes in the library. Select the cause you would like to add and it transfers from the library to the tree. Let's do that another time. Select the event to add a cause to, select the cause in the library, and then it transfers to the event. There is no requirement to use the library. Investigators can simply add causes as they become aware of them. Investigators will naturally be asking why the cause developed and adding a string of further causes. This process, pioneered by the Toyota company, is called 5 whys. Not because the string of whys is always 5 long, but to encourage investigators to dig deeper. There is a third way to add causes to the tree, by using Professor Reeson's causation model. Select the event or cause that you wish to add a cause to, and then select the Cause Models button. Select Insert ICAM and choose from the string that is most appropriate. You can add the cause as a single box or as a series of whys. Add information to the boxes to explain further. The causation model can be customized to suit your particular industry. Here the model has been developed for the aviation industry. The basic causation model has been expanded to include scenarios that are more meaningful to the investigation team members. The investigator chose to show the boxes as a string of boxes. Each of these could be further developed to dig down into the detail of the causes. Each box on the tree is associated with these items on the menu bar. Investigators can add evidence. The boxes are initially shown with a dotted border to indicate the box is a possibility. Investigators click here to show the box is confirmed by hard evidence. This causes the border to become a solid line so that it is easy to see which part of the tree is hypothetical and which parts have been confirmed. Actions may be added. For example, a laboratory report might be required. Actions help to keep track of the hundreds of minor things that may need to be defined, delegated and tracked. The detail field provides a place to store notes, references and comments as more information becomes available. Criticality may be assigned to assist investigators to keep track of which items are important. Time may be associated to event boxes. Note that as these items are added to leaves in the tree, coloured buttons appear at the bottom of the box. Clicking on the coloured button shows the detail. Now the investigation is well underway, with a strong picture developing of events before and after the incident and factors that contributed. It is now appropriate to use Professor Reeson's causation model to stimulate further thinking about causes and to begin to analyse them. We do this by labelling each of the causes so they may be sorted and arranged to reveal the underlying systems that led to the event. This job is made easier because all of the causes that were added using the fishbone brainstorming technique, or the ICAMs and other models, are already labelled. Select a cause and the existing label is shown. Labels can be assigned to causes by selecting the cause and then by selecting the appropriate path in the ICAM model. In this case, the investigator believes that training is a factor, so the organisational domain and the training subdomain are selected and the selection is saved. The investigator decides to add an additional label as it seems the pilot did not apply an appropriate defence to protect against the situation of an engine failure. The appropriate defence for a single-engine aircraft would have been to the maintenance of a height sufficient to glide to safety. The labels are shown. The investigators can remove a label by clicking on the garbage bin symbol. Our example has identified only a handful of causes, but after considering why the engine failed, fuel contamination issues, flight planning, and many other topics, we will have literally hundreds of causes to consider. Labels become very useful when we come to analyse causes using reports to sort causes and look for patterns that might show systemic weaknesses that may have contributed to the problem. Investigators use the causes report by first giving the report a name, selecting whether details and evidence will be printed out, choose whether to show causes from the library and the time before and time after trees, choose which label models to include, change the order of the various labels by sliding the buttons up or down. The report may be delivered as a PDF or as an Excel report for those wishing to copy and paste information. The resulting report gathers causes together within the ICAM's domains to assist in seeing patterns. SHEQ2GO also has a sophisticated report builder which lists all fields used in the user configurable forms. Slide buttons representing fields across to the report panel to define which fields will be shown in the report. Slide the buttons up or down to change the order in the report. Graphs are defined in the same way using the Report Designer button under the Admin menu. Select the report to be edited and select whether the report will be a bar chart or a histogram. All fields that contain data that might be graphed are listed. Drag and drop the field that contains the titles for the bars you would like to see in the chart. In this case, the bars in the chart will have the pilot's names, so the bar will show the number of occurrences that each pilot has been involved in. All fields that might be usable for filtering information are shown and can be dragged across. Here, information will be filtered by investigation date. So the user will be able to define the date range that the chart represents. You can have multiple filters. Now select your preference for how the graph will look and edit the legends for the axes. The graph can be shown on the screen or printed to PDF or other formats for additional editing, and annotations may be seen on the screen for group presentations. The SHEQ2GO software is massively configurable. The options under the Admin button allow the system administrator to customize which tools and options will be available, so the problem-solving tool matches the needs of your particular organisation. Find out more by sending an email to us at RCART.